Okay. In this section, we really have two goals. Number one, we want to be able to simplify trigonometric expressions. And number two, we want to be able to solve trigonometric equations. This will come very naturally to some of you. To those that it doesn't come natural to, we got to work through the confusion. You got to ask for help. You may need to come in early someday to get help, or you may need to stay late and ask for help later on in time. Just because you're a nice kid doesn't necessarily mean that we're going to get the information. So we got to work hard and work through it. If you flip to your very last page, this is a list of many formulas. Now, this is the regular track trigonometry course. Do you get college credit for this? No. And so, therefore, I take off a lot of material. For example, you do not have to know how to do this. You can cross it off. Second of all, I will not require you to know how to do this. Third of all, I will not require you to know how to do this, or this, or this, or this, or this, or this. The fact of the matter is that you already know this part right here. Conversion of degrees to radians, or radians to degrees. You already know the area of a sector. You already know how to find arc length. We've already tested on that material. You've known how to do it. You already know how to find area of a triangle. That was your last test. You already know the law of cosines. You already know the law of sines. We've already done those. We've also already learned Pythagorean identities. So we really just have two new things. We're going to work with this, and we're going to work with this. This is the sheet that you get to use on your test. If you flip it over, there's even some better examples for you. And today, we are going to focus on these main 4 examples here. Have you learned before that tangent is equal to sine over cosine? Yes. So that's not new. That's a review piece. You can also write tangent as 1 over cotangent. We are going to focus on this part today. You've also learned that cosecant and sine are reciprocals, and that secant and cosine are reciprocals. And cotangent, since it's the reciprocal of tangent, can be written as cosine over sine. We're going to use those 4 identities today to simplify trigonometric expressions. Here we go. Sine times secant is something. It's something different than sine secant. And one way to simplify trigonometric expressions is to rewrite in terms of sine of theta and cosine of theta. Sine of theta and cosine of theta are, well, they're nice because everything can be rewritten with a sine or a cosine in it. For example, does sine already have a sine or a cosine in it? Yes. And I'm going to write it as sine of theta over 1. Does secant have a sine or a cosine in it right now? They're just working outside, don't worry. The secant, we don't see a sine or a cosine listed. So I'm going to rewrite it. What on the previous page do you see that I can rewrite secant as? You might want to tear this sheet off. What can I rewrite secant as? 1 over cosine. And if we do that, we get sine of theta over cosine of theta. What is sine divided by cosine? You see that somewhere on your page? It's tangent. So that is simplified. It turns out that sine times secant gives you tangent. As you kind of try to let that absorb, let's look at example B, and you can see how this will work out. Do I rewrite cotangent or do I leave it alone? I need to see sine or cosine. So do I rewrite it or leave it alone? I rewrite it. How do I rewrite cotangent? Cosine of theta over sine of theta times, do I need to rewrite sine? No, I just leave it. What happens? We don't cross multiply, we just look for things that cancel. The signs cancel. And we get let's look at C. How do I rewrite secant? And if I ask, how do you rewrite secant, and you don't know that answer, all I can do for you is this. All I can do for you is give you this page that says secant is 1 over cosine. If you say you don't get that, there's nothing I can do for you. Secant is 1 over cosine. All I can do is provide the information that says this is what it is. You have to be able to look at it and write it down. So we have secant is 1 over cosine. Cosecant is, does anything cancel? Is sine times cosine something special on the page? No. The fact is that this doesn't simplify. I have one example in there to show you guys that this is already simplified. Nothing cancels. It can't be rewritten in a nice way. Writing as 1 over sine times cosine isn't really helpful at all. And so secant times cosecant is really as good as it gets. Cotangent times secant. How can you rewrite cotangent? Secant? What happens? Cosines cancel, and I'm left with 1 over sine, but I'm not done. What is 1 over sine? It is cosecant. And so it turns out that cotangent times secant is cosecant. You try E and F on your own. See if you can come up with E and F. That's a really good measure to see if you know what's going on today. Okay, let's see what you got. We've got sine over cosine times 1 over sine. 1 over cosine, can that be rewritten? Secant. Next one is 3. We'll try it. We got 1 over cosine times 1 over sine times cotangent is cosine over sine. Cosines cancel. 1 over sine squared Cosecant squared. So sine times sine will give you sine squared. Yep. Okay, let's divide them. We'll take tangent divided by secant. How do you rewrite tangent? So that's tangent. How do you rewrite secant? 1 over cosine, right? Now what do I got to do? Multiply by the reciprocal. So we multiply by cosine of theta over 1. I'm left with sine. Cosecant, 1 over sine over cosine over sine. What do I do now? What cancels? So what do you have? And what's 1 over cosine? Secant. Letter I, sine of theta over 1 times, how do you rewrite secant? Over cosine over so I always want to write it. So a lot of people are tempted to do that. You can rewrite tangent as 1 over cotangent, but you always want to choose to write it using sine and cosine. And so instead we'll choose sine over cosine. What do you get in the numerator here? Sine of theta over cosine of theta over sine of theta over cosine of theta. What is sine of theta over cosine of theta over sine of theta over cosine of theta? You take anything divided by itself, you get 1. You try J on your own. Try J on your own. Okay, let's see what you got. You should have sine over cosine over cosine over 1 times 1 over sine. And you get sine over cosine over sine. Are those the same things? Are those the same? No. They're not the same. If you multiply by the reciprocal, we get sine over cosine. And so sine times sine is sine squared. Cosine times cosine is cosine squared. What is sine squared over cosine squared? Tangent squared. Last one. Sine squared over 1. Cotangent would be cosine over sine. And cosecant would be 1 over sine. So what's going to happen? both signs will go away. Here you have a sine squared in the denominator. They'll cancel the sine squared in the numerator. That's a total of a cosine of theta. That's your answer. So theta is just an angle. So if you cosine's an operator, it would be like writing plus. Plus what? Plus 5. So cosine of what? Cosine of, say, 30 degrees. So theta is a variable that represents whatever that angle could be. Sure, yes. And some people, instead of writing theta, they just start writing x because they don't like writing the theta. That's fine. Okay, so you have a book assignment here. And write it down. Again, you don't want to put off this work, folks. I think I warned you quite clearly. There's 8 problems. We did 11 in class in 15 minutes. So you should be able to do that. I want to emphasize you must show your work. As always. So if you see tangent of theta divided by secant, okay, I don't simply want to see you just write sine. Rewrite it as we did in class and show what cancels. Okay. Now, if the problem was simplify sine over cosine, not too much that you could do to simplify that or to show your work other than just stating that is tangent. Okay, so I get that. But please make sure that you're showing your work through that process. Okay, you could actually get the assignment done in the next 20 minutes here.